Hello, everybody, and welcome to the class. In our fifth module here, we will talk about the data science and analytics. We'll discuss important parts and important properties of very common, well-known names and common known ideas, but we'll look at them from the data point of view for the cybersecurity. And this way we narrow our focus into this specific very fine line parts. So I'll go ahead now and start my slides. So this is today's lecture, and we'll talk about an introduction to data analytics, especially focusing on big data and analytics. So the definition will be like that. What is data analytics? We are talking about data analytics is the science of analyzing raw data to make conclusions about information for human consumption. We have a lot of data, different shapes, different format. Usually all the data is optimized for machine control, so the computer or routers can be easily working with it, especially including IDS, IPS, firewalls. All these devices are very easy to work with bits, but for human eye and human perception, we need to change it a little bit. This is why we need data analytics. It's important to notice that data analytics is a broad term of a lot of technologies that can diverse type of data that we need to analyze. So any type of information can be studied and be a subject for data analytics, including traffic, including packets, time of arrival rate, type of users who are on the system, what times they are logging in, and what type of information they're sending in. The data can be it's like almost like a dough shape where you can actually get whatever you want out of it. So any subject can be a part as an input for any data analysis later on, because data analytics actually gives you an insight of what can be improved in action later on, because you're basically looking for something that you don't know what it is inside the data. It actually can reveal trends and metrics that otherwise it could be just lost inside in the data as a part of mass information loss or something like that. And this is why data analytics is very important. And we use this process to optimize processes to increase overall efficiency of the system. Some example will companies or industry use data analytics. One of them is in the manufacturing companies. They can record runtime, downtime, work queues, or machinery for better workload later on and better performance, because they want to save time and increase the productivity, for example. Some of them can use the same information to save electrical bills or saving daylight expenses and so on. Another example that close to the computer science is the gaming companies. They use different type of data just to set reward to schedule players to keep the majority of players active in the game. So they set what time they should set the rewards, what time they have to increase this, membership and so on, getting from the time when the player logged in, what time of the day, how it's related to the holidays, and how it related to specific political or geographical events. Another example for content companies, like all of us see and experience that almost every day, they just want to keep the user clicking or watching specific advertisement just to get more money out of it by using the data and what interests the users. And this is how they capture all the data from your social media to make you involved and check videos that you normally would never check by using this data, and includes their profit. So what is the steps of any data analytics process? Very easy, 4 steps. Step number 1, to determine the data that are required. You need to exactly know what your data want to collect. Maybe it's just sparsed or separated in time. It can be in traffic, it can be in size. What type of data you want to do? Determine what's your data. Then you determine what is the data value, the numerical. Is it divided by category or divided by numbers or divided by dates, and so you need to get this information about this just to determine what's your data. Number 2 is to collect the data. 2 methods, no more. One is automated, using a software or hardware to collect, like we are doing in our hands-on for like Snort, for example, or even Wireshark, automated process. Or it can be super-personal if you need to get human-related data or data that actually is not captured by any device but affects the system. So this information can be get manually. Step number 3, organize. Using this information is just even not halfway yet, because usually when you get all this type of information or all this type of data, it's sparse, usually incomplete, a lot of zeros, a lot of NA or like non-acknowledged, which really can mess up your machine learning later on. So we need to organize the data, and there's 2 ways to do that. For example, using specific software, even Excel or Access will be fine to get just to normalize the data. Some of you already had the database course when they teach you how to normalize the data. First normal form, second normal form, so on. We at least need to get to first normal form. We remove the duplicates, remove the zeros, and make the data available as much as we can. And the 4th step before starting the process is to clean before analysis. Ensure there's no duplicates, ensure no errors even, and ensure that the data is complete. This is the 4 steps to do for the data analytics. After that, we'll discuss what types of data analytics we have. Again, we just will study there's many other types, but for our scope here, we'll look on 4 data analytics types. Type number 1, we'll call it descriptive analytics. So it describes goals over a given period of time. We have some process or some network or some security system that was running for a bit of time, and we need to describe what goals are in this analytics. So the result of it will be just knowing what is the goals or where the system is going. Diagnosis analytics, it focuses on why something happened. For example, there was an attack and we don't know why it happens. So we need to get all the data, merge it together, try to find relation inside the data, and then we can diagnose what happened exactly in the system. It can involve very diverse data input, and a little bit of hypothesis need to be done to select which data should be involved inside the system. Step number 3 or type number 3 is the predictive analytics. This is just to answer the question, what is likely going to happen in the near future? Looking at the data, predict what's next. Are you going to have a system failure soon? Are you going to have an attack soon? Or maybe some device gonna just be disconnected? You predict from the data, from the logs, from the errors that they sent. If there's a software that needs an update for too long and suddenly there was like a breach to that specific missing update, you can expect that you will be attacked, or your network will be attacked, I mean. And the 4th type is the prescriptive analytics, which is suggests a course of actions. It tells you, okay, this is your system now. You're supposed to do this and this and this based on your data. Something very close to penetration testing, but penetration testing will be the input to your next step, what to do next. And this is why data analytics are used. Some skills are required for data analytics, which we can put them in these 5 categories. One of them, data mining. Second is machine learning, natural language processing, statistics, and visualization. This is the five parts that or skills that are required out of the data analytics. You can use them to get more information readable to the human eye. And we need to discuss here another point that data analysis is related very much to the statistics because it actually data science or data analytics increases the power of statistics because now you're dealing with huge amount of data when you actually can very closely use assumption of the independence of the packets. Additionally, it gives you a massive storage operation. It can use using a database, regardless it's just a database management system or relational database management system, as well as data discovery and data mining. All these concepts will actually coexist for a long time now. And if we look at the historical structure of the data and statistics, we can look at like that. First time they mentioned a database management system, it was back in 1960s. 10 years later, they started to get the relational database and it became like a big thing. All the companies went from paper archive to database archive and so on. Then they realized that the data is big and what we're gonna do that. So in 1980s, the word of data mining started to come in place. Just how to dig inside the data and to find more information that was hidden from just plain text data from the databases. However, in less than 10 years, or like less than 20 years, 17 years actually, the first word mentioned was the big data because the amount of data started to grow exponentially. And this is still before the huge bang of social media and all the video content that we have now. And right in mid 2000s, we have the data science analytics, and it's become very popular, and all works are requiring some knowledge about data science and analytics. So you can see how the amount of data, if we can look at this scope here, we can see actually if we draw a graph of the size of the data, it will go something like that. You just go to data mine and suddenly it go to exponential growth and with no ending to the amount of data that we can actually imagine. So in our study here, we will look at these four concepts: the big data, machine learning, data mining, and data analytics. Let's go through each one of them. For the big data, actually a relevant term because what is big? But big actually, I would say anything that bigger than the human eyes it can work with. This is the best definition for big. It's not in terabytes, about the capacity that the human eye can work through the data to get information. Also, the way of processing it, this is what defines your big data. Are you using a single computer or a distributed system? Are you using a cloud technology or just a local machine? All of that gives you an idea that you are now in big system. Three concepts that we look here in our course, it will be the volume, variety, and velocity. Actually, there are more models for big data, but in our course we'll use the three, and we're going to compare the two of them. Some of them use more than five even. And actually, the big data is always technology based. And to get a comparison between these two models, this is what I mean. This is a model that we're going to use in our course. It's just volume, variety, and velocity. Other models, it talks about the 5 V's, which is the volume, velocity, variety, value, and versatility. In our case, for velocity and value, we value every packet. Come on, we'll value every traffic happens around because we're in cybersecurity here. We can, yes, we have different assets, but within the asset itself, doesn't matter which asset is. The step of recognize the value of the data is done previously in the collection phase. So in the collection phase, we already agreed that if something is variable, I will go to full packet capturing, this kind of stuff. But if it's less asset variable, it will be going for like p string or p cap capture. So it's already another layer. We're going to next layer, which is data scientific. All the information that we get have the same value, high. That's it, full stop. So this is why we omitted in our volume the component of value and veracity out of it, because we care with everything and we just will look at all the data to classify by volume, variety, and velocity. The next part is the machine learning, and machine learning is just a tool that helps human to try multiple solutions to solve a problem. We make the machine does the repetitive work that we don't like to do, because it can do it very fast, as well as we can remove the human error from mistyping, misentering, and so on. So this is why we love machine learning. However, data mining, it's the next step. Now we're trying to discover patterns inside the dataset. Remember that data mining doesn't require any hypothesis to be set first before we mine for the data. It's just a way to discover new knowledge. Some of the steps is the data source, data exploration, modeling, and deploying models. But we never set a hypothesis in data mining for our cybersecurity test. On the other side, for the data analytics here, it's not data mining. It starts with a hypothesis, and this is the most important part, important discussed between the data mining and data analytics. Data mining doesn't require any hypothesis, but data analytics starts with a hypothesis. Usually it's a question. For example, does network traffic affect the sick leave of the employees? Just a question, and see what is the outcome. It's usually very computational challenging, but the output is very interesting. So we'll go with two technologies that are used the most here: machine learning and cloud computing.